Welcome once again, advanced algebra students. We are ready for today's lesson, which is actually the last section that we are of new material that we are going to have, and that is going to be the law of cosines 14.5. So the notes here shouldn't be too long. So let's consider, we had the law of sines last time, but I don't know whether you realize this or not, but what about this situation here? Here's a situation where the law of sines won't work because I don't have an angle and a side opposite the angle. Notice here I've got an angle, but I don't know the side opposite. And I have two sides, but I don't know either of the angles that opposite those. So what am I supposed to do with this situation? Or how about this situation? Here I know all three sides. How am I supposed to find an angle? I can't make any ratios if I don't have an angle. So in this situation, we need something other than the law of sines. We need what is called the law of cosines. So here's the way the law of cosines works. If we have a triangle like this, notice it's not a right triangle, it can work with any triangle. And we have our angles labeled ABC, and then the corresponding sides that are opposite those angles labeled ABC, where A is opposite A, B opposite B, and C opposite C. Then we see the law of cosines states the following. Now I'm going to show you what looks like three formulas, but it's really just one formula. And you only have to think of it as being one formula as well. So it's this formula right here. A squared is equal to B squared plus C squared minus 2bc times the cosine of A. Well, in this situation here, notice the key is that this is if you don't know the side A. So this is like this situation up here where I didn't know x. So that's like calling x the side A. The key is that the side that you don't know has to go here, and the angle that is opposite that side has to go here. So notice that's if you know the 58 here, you don't know this opposite side, then you can use law of cosines. Now, it doesn't matter which side you call A. You could use the same formula and do this. Notice the only thing difference here is that whatever side is here, this is the opposite angle, and the other two sides go there. Doesn't matter what order they're in. Doesn't matter what you call A, B, or C. The key is whichever one you call side C, the angle has to be here, and then these two are the other two sides. Doesn't matter. It's really not three separate formulas. It's just one formula. The key is you must match up whatever side here with the angle here. Doesn't matter what you call A, B, or C, so long as you pair up the corresponding pieces there and there. So let's solve this situation here. So I'm going to call this side A, and I'm going to call this angle A. So I know that x squared, putting x in there, is going to be equal to, now it doesn't matter which one of these I call B or which one of them I call C. I can do it either way, because when I square them and add them together, I'm going to get the same thing whether I took 4 squared plus 3 squared or 3 squared plus 4 squared. It's going to be the same thing. Minus, and once again, when I multiply the two sides together, it doesn't matter the order they go in. So in this case, I'll go 3 times 4, but it would have been just the same as if I would have gone 4 times 3 times the cosine of the angle that I know there of 58 degrees. Now remember, I'm trying to find x, so to find the answer to a squaring problem, I will take the square root. So I know x would be equal to the square root of this whole side right here. And this is what I'll enter in my calculator. So these are always calculator problems. You just enter that whole thing there under your radical with your calculator. Once again, you need to be in degree mode or use the degree symbol and make sure that you enter that correctly and it looks like that. It's very important you don't accidentally only have the radical over some of it. You actually have to have inside this whole thing inside the radical. And once you do that, you should get out your calculator, practice entering that, and you should get 3.505. So we find that this side over here was 3.505. Okay, well, how about this other situation? How about when we're looking for the angle? This one's a little bit trickier. So to solve for an angle, we're going to do it like this. Notice the key thing here is in my formula, I must match up the angle here. That's going to be my y. And whatever this is, this has to be the side that's opposite. So if I put a y in here, that means that 3 is side A. If I call this angle B, or if I thought of it like this and I said this was angle C, then 3 would have to be the side C. The key thing is you just have to match up the angle you're looking for here with the opposite side there. So in this case, here's my basic formula. So what I'm looking for is I'm looking for this angle Y here. So I'm going to make sure that the 3, well, I guess, notice I'm going to actually go ahead and solve for the cosine of A. So this is another way to look at doing it. So if I solve for the cosine of A, I took my A squared and I added, so what I'm trying to do is I wanted to get this here to the other side. So I want to subtract the A squared. So this is canceling out the A squared. This, if you don't have to worry about all this, if you don't want to, eventually what you do is you get to this. A is the inverse cosine of this B squared plus C squared minus A squared all over this 2BC. So to solve in this case here, I just need to, I know the angle I want is the Y, so I'll put here, the key is this A squared has to be the 3. So this has to be the 4 and the 3.8. So the key thing is the side that I subtract has to be the side that's opposite the angle Y. Go ahead, plug that into your calculator, and you'll get 45.149 to make sure you can do that. Okay, that's the law of cosines. Once again, if you have the formulas and you can have those formulas, I'll let you have those on a note card for the test. Just make sure you can work with the formula and find the answer. Okay, the homework is 7 through 17, all of them. All right. Sorry this video is late. Got very backed up today with an app not working and then conferences, but here you go.